All right, let's grab our practice block and get ready to start our project. You'll be supplied with a rough cut piece of material. You're going to need to prep the stock like we showed you earlier. And let's go over that again. You can see we've got big burrs on it. Simply take our file. We're going to remove those burrs. It's your file at about 45 degrees to the workpiece. We're going to go over all of the cornered surfaces, removing a burr so it doesn't affect the location of our part when we put it in the vise. See, a lot of very skilled people spend hours on a part and then neglect to remove a burr, clear the chips. All of those hard hours are for naught at that stage of the game when we wreck a part. So be very conscientious in keeping everything squeaky clean. All of our edges burred while we're machining on a part until final inspection. All right. I think that pretty well covers it. We're going to go ahead and take a rag now and wipe that part off, getting all the little filings and chips off of it. Okay, we're going to go over our vise jaws, making sure that they're clean and chip free. Grab a felt pen or a little Sharpie marker. Let's take and put an X on the front face of our part, just as a reminder as to which face goes up against the master jaw in our vise. We're going to take our block, push it up against there, take our round piece of bar stock, put it in behind the part. This is going to force it up against the jaw, which is our master jaw. With everything nice and tight on the vise, we're ready to install our collet. We're going to surface the top edge of the part with a 3/4 inch solid carbide end mill. All right, we made a speed change. We're going to turn the 3/4 cutter at around 1750. We're going to really put some horsepower to it this time in our squaring operation. Bring the cutter down in contact with the work. We're going to lock the quill in place. We're going to take about a 20 thousandths cut in order to prep this edge. Don't forget to don your safety glasses. We're going to give the cutter a little shot of WD-40. We'll raise the knee 20 thousandths. Take our first cut. All right, that bulked off a lot of our material. Now let's go back. Since we can use this as a finished edge now, we'll take another 10 thousandths off. We'll slow our feed rate down a little bit, make a finished pass across our part. Remember to have a smooth cranking of the hand wheel. We want a nice finish. We don't want to have a jerky transition as we run the cutter across our part. Take the cutter all the way to the end, index over. Again, nice smooth movements. Give ourselves a shot of WD-40. This will give us a nice finished pass across the top of our workpiece. Go ahead and shut our machine down, loosen the vise. Grab a paper towel and we're ready for a little cleanup. Wipe the chips off of our part, clean our vise jaws out. It's real important now that we start this squaring operation that our vise jaws are absolutely, positively, spotlessly clean and free of any chip or debris that may affect the accuracy of our part. Grab our file and we're going to break that sharp edge across our part. Use our rag, get all the chips off. Okay, we're going to put the same face up against our master jaw now. The area that we just machined goes on the bottom. We're now going to cut a parallel surface. Install your block. We're going to take our two fingers, we're going to press down on the block. Tighten our jaw. We'll come back, let's take another 20 thousandths pass. Okay, now we've created two parallel surfaces. We can remove our block, and at this stage of the game we've got a couple of options. We can continue the squaring operation, or we can go ahead and cut our part to dimension at this time. In order to save time, let's do that. Using our dial calipers, we're going to measure the width of the part. We get 2 inches 649 thousandths. So our specification calls out for 2 inches 625, or 2 5/8 inches. So we're going to need to take 24 thousandths off of the part. This time we're going to insert it back in the vise. Remember, this is our final pass, so we don't want to muck it up by having a chip or any debris in. Put our bar in the back, cinch our vise down, turn our machine on. We're going to elevate the table on the Z-axis 24 thousandths. Going to lock the knee in at this time. We're going to take a nice finish pass across our workpiece, so slow your feed rate down just a little bit. Okay, our part is now dimensioned in one direction. Go ahead and wipe it off. We'll grab our dial calipers and we'll check it for size. Okay, exactly 2 inches, 625 thousandths, give or take a couple of tenths. Okay, we're going to keep our reference now. We're going to run our file across our part, taking away those sharp edges, removing any burr that may have been caused during that machining operation. And wipe our part off, keeping it spotlessly clean. Go back and clean our vice jaws out again. We're going to grab a couple of parallels at this time. Support our workpiece as we begin another fly cutting operation. Remember the little tip and trick about spraying a shot of WD-40 or any kind of spray oil on the inside of your vice jaws when we put the parallel in place. We'll just friction fit and hold the parallel up against the vice jaw, eliminating the possibility of any chips getting in and around or underneath our parallels. Run our hand over the top of our block, making sure we've got a nice burr-free surface that we're going to set down atop the parallels. Remember, this is the surface that we had clamped up against our master jaw. So we're going to reference that off of our parallels now. We're going to go ahead and extend, push our parallels back, center the block in the vise. We'll go ahead and fly cut to dimension. Now remember, with our left hand, we're going to take and push down on the block as we gently close the vise, snug it down. Keep our hand on top of the block as we loosen the vise to detect any misalignment that may occur during the clamping process. Everything feels nice and tight. We'll go ahead and remove our cutter and replace it with the fly cutter. Okay, now in the fly cutting operation, we talked earlier about using the power feed. This is a real good time when you're fly cutting to go ahead and kick back a little bit, concentrate on the next step that we need to machine after we fly cut our surfaces and bring the part to dimension. So we'll go ahead and take advantage of the power feed, give our arm a rest. You want to center the fly cutter over the part so we get a nice uniform facing cut. Let's go ahead and raise the bed a little bit so we don't have the spindle sticking down quite so far. Okay, we're going to go ahead and bring our cutter down, come in contact with our work, and we're going to lower the bed an additional 5/1000ths. We need to slow our speed down. We were turning the 3/4 inch solid carbide end mill at 1750. Now we're using a 4.5 inch diameter fly cutter. So we're going to shift gears and turn that at 660 RPM. Okay, we're going to back our cutter away from the workpiece just a little bit. Turn the machine on. Advance the cutter. Raise the bed to the point that we just come in contact with our workpiece. Now let's take a look at the servo feed, take a little refresher course on that. Got our power feed, switches on the bottom. We're going to turn it on. Our little knob that you see here indicates the direction that the table will move when under power. This direction allows the table to move from right to left. This direction allows the table to move from left to right. So we're going to move from right to left on the first pass. We've come in contact with the workpiece with the fly cutter. Let's take around a 25, let's go a 20/1000ths cut on the first pass with the fly cutter. Raise the knee, lock the gib down, give the top of our part in the fly cutter a little shot of lube. We'll go ahead and advance the material into the cutter. Okay, you can see the feed rate that we're turning. Again, this is infinitely adjustable. Our servo feed is on a rheostat, so we've got plenty of adjustment there. Give ourselves a little shot of WD-40. With a little bit of practice, you should be able to advance the cutter across the workpiece almost as smooth and uniformly as our servo feed. All right, once the cutter has cleared the workpiece, go ahead and return it back to 0, stop it, change our feed direction lever back to neutral, and then manually advance the cutter away from the workpiece, turn our machine off, and we can inspect our part. We've got a nice mirror finish. On the top, we're going to go ahead and remove the burr on both sides of the part, flip it over, surface that side of the part, check it for thickness, and adjust and machine to dimension. That dimension is 1 inch 200 thousandths. Again, get in the habit of wiping the heel of our hand all around the part, detecting any burr that may be present. Take our paper towel, clean the tops of our parallels off and the vice jaw. Now, it's a good idea at this point to give us a general idea of how much we can take on that second pass. Just go ahead and grab our dial indicator, our dial calipers, excuse me. We're going to go ahead and take a rough measurement. We've got 1 inch 237.5 thousandths. So if we were to take 30 thousandths off in this next pass, that's going to allow us a finished pass of somewhere in the neighborhood of 5 to 6 thousandths. We'll go ahead and take 30 off, pull the part out, check it for dimension, and then take our final pass to bring us into specification. Again, push down on the part on top of the parallels with the left hand, gently close the vise tight, back it off, feel for any shifting or disruption. We want to make sure that that part stays flat on top of our parallels. All right, we'll fire up the machine again. We're going to reverse direction on the power feed. We're going to raise the knee an additional 30 thousandths. Lock the gib. Give our part a shot at WD-40, and let's advance the cutter. So you can see how efficiently a fly cutter is capable of surfacing our workpiece. If we were to take the 3/4 inch cutter, we're going to be running back and forth across that. It's going to look like a maze with the cutter tracks across the top. All right, once the cutter has cleared the workpiece, we can shut off our power feed, feed selector direction to neutral, manually advance the cutter away from the part, shut our machine down. We're going to pull the part off, burr it, and check it for dimension before we make our final finish pass. All right, the part's starting to look pretty snazzy now. Got some beautiful finishes on our fly cutting. Got a good sharp cutter. We can just use that as a signal mirror and call the cavalry from the other side of the valley. All right, let's take our dial calipers and check for dimension. Okay, we're at 1 inch, 209 thousandths. So we can go ahead and take that 9 thousandths in one more pass, and that'll bring us within specification on that dimension. And this has allowed us to square the part in 2 directions. Okay, remember we hold the part down, snug our vise up, back it off, tighten it up again. Go ahead and turn our machine on. We're going to raise the bed 9 thousandths of an inch. Lock our gib down. Run over to the power feed and let's go. Remember, if this were a production line, we would simply go through all of our blocks and resurface and do everything while the machine is set. It's very important when we do production that we try and take advantage of as many steps as we can simultaneously. We don't want to be adjusting the cutter for each and every part that we do. Start an assembly line, continue all the way through, finishing that operation, index all the parts over, surface them all to thickness at that time. All right, let's pull our part out, check it for final dimension, and then proceed with cutting the block to length. If you establish good work habits early on in your machining career, you're going to be really hard to break. Always get in the habit of burring the parts. Don't get in a hurry. Don't rush the job. When we start rushing, that's when mistakes happen. It's really hard to put the metal back on. You see how easy it comes off, but it can be a real pain in the tail to put it back on if we make the proverbial sausage too short. All right, that last pass was 9 thousandths of an inch and should put us at exactly 1 inch, 200 thousandths. We're actually around 1 inch, 200 thousandths, and maybe a tenth or two. So again, within specification. Now, let's go ahead and cut our block to length. We'll wipe our parallels out again. Another thing that can occur when you get a little sloppy and you leave a chip in the vise, especially when you're working with aluminum or parts that have been ground, is that chip will get between the vise jaw and the workpiece, and when we compress the vise, it embeds the chip into the side of the part. If these parts were cosmetic and they were going to go to anodizing when we're done, we want as nice and smooth and uniform a finish as possible, because once we put the anodizing on, those nicks and dinks are going to show up like a sore thumb. Right, we're going to push our parallels back a little bit so we can protrude a little bit of our part from the vise jaw. Clamp it down. We're going to go ahead and go from a fly cutter back to an end mill and face mill the ends of our part. Got our cutter choked up pretty far. Go ahead and center our cutter with the quill, lock it down. We're going to speed up the RPM a little bit on this one to around 1115. Rough that in the conventional milling form. We'll come back across it in a climb cut. And lock our table down. Going to take 10/1000ths in this pass. Then come across with about 2/1000ths for a finish cut. Loosen the gib. Make our adjustment. Lock the gib down. We're ready for a final pass. Nice and smooth and consistent. We crank the hand wheel on the Y-axis. We want a smooth, uninterrupted cut. Alright, get our cutter out from around the part, burr it, take a roughing pass, a measurement. We'll have cut our block to length. That dimension we want to cut it to is 3 inches 900/1000ths on the money. You're going to be graded now by the accuracy in which you machine your block to these dimensions, so take your time. Don't get in a hurry. We're trying to instill good work habits early on. If you'll take the time to do that, you won't be disappointed. Okay, that's got a pretty clean surface. Now let's stop and take a measurement. Okay, we're 3 inches 980/1000ths. If you have the advantage of a digital readout, now's the time to reach up and let's zero that. We can quickly and efficiently peel off that additional 80/1000ths. It's going to be done in the x-axis now. Okay, we're going to take about 40/1000ths off in that pass. Climb cut another 12 coming across it. Okay, now we're going to want to kind of sneak up on this dimension a little bit. So let's take another climb cut at 65. Wipe the surface of our part down, make sure that we don't have any chips that may affect the accuracy of our measurement. We'll take another measurement with the dial calipers. Okay, we're 3 inches 916/1000ths. So at this point I'd reach up and simply re-zero my dial. Know that I want to take 16/1000ths off. So I'm going to go ahead and take another 6 on my pass across. Might as well take a little metal with you each time you go, even though it's in a climb cutting fashion. Go to 12. Then 16 on our last pass. And we're going to lock the table down. Here we go with a nice, smooth, uniform rotation of the hand wheel. Complete our finished pass, bringing our part to dimension. Loosen the gib, back our cutter away, we'll wipe our part down and okay, we're exactly 3 inches 900 thousandths on the money. Okay, we've completed the squaring operation. We've cut our part to dimension in 3 directions, thickness, width, and length. Now it's time to move on.